Hi, ch12. I heard there may have been a problem with the previous video, so I'll resend that one. So what that one had looked at was balancing redox reactions using the half reaction method, where you split the two reactions, you split the redox reaction into two half reactions, you balance them individually, and then you combine them after multiplying in order to get electrons gained equal to electrons lost. This is another method. This is using the oxidation number method. So remember we had looked at how to go about calculating oxidation numbers. So some of you might prefer this method over the other method and vice versa. So you go with which one that you find easier. So in this method, there's the following four steps. So you assign oxidation numbers that are involved in the change in oxidation number. Okay, so that's the key part there. So the ones that are going up or going down, and then what you want to do is you want to multiply both of those reactions in order to get the change in oxidation number the same for both of them. And then you can, after you do that, you can start putting in things in order for it to be either acidic or basic. Okay, so I'll show you what I mean by that. Let's start with this one here. So the first thing you can do is you can balance the major atoms. Okay, so we balance the N with the 2 in front, and then this N over here has 2 in front as well. Okay, now what you want to do is you want to start assigning oxidation numbers. So for example, arsenic here is in the elemental state, so it'll be 0, and here it'll be +3. So where I got the +3 from is oxygen is going to be -2, and there's 2 of them, so that's -4. Hydrogen's +1, and so arsenic has to be +3, so +4 from these two, and then -4 from the oxygen. Okay, and so now what we do with the arsenic is we say what this means here is the change in oxidation number is equal to +3, right? Because we went from 0 to 3. Do the same thing with the nitrogen. Okay, there's a bit of a hitch here because you have the 2 ends there, so I'll show you how you go about doing that. So nitrogen here is +2 because oxygen is -2, and then the nitrogen here is +1. Okay, because again oxygen is -2, and you have 2 nitrogen, so they both account for +2, so individually they each are +1. So what's happened here is the change in oxidation number is -1. So when you do this, you should always be finding that one goes up and then one goes down. Now, where this 2 is here, that 2 is accounted for this 2 over here. Okay, so that's what we mean by the change in oxidation number per atom. Okay, so that's what that means. So that's why we multiply this by 2, because we had to put a 2 over here. So now what happens is this one has a change in oxidation number of -2, right, because we multiplied by 2, and this one over here is +3. So we want to get the two the same, so what we do is we multiply this one by 2 and this one by 3. So that way we get the change in oxidation number here to be +6 and here to be -6. Okay, so this is what you're looking for. You want the change in oxidation number to be the same in opposite signs. Okay, so the reason why I draw these lines down here is so I know this one I'm going to be multiplying by 2. So that means I'm going to stick a 2 in front of AS and a 2 instead of HASO2. And this one I'm going to be multiplying by 3. So this is going to become 3N2O4. And then there's already a 2 here, so I multiply that by 3, so that's going to become a 6. Okay, so I've got 6NO, 2AS, 3N2O, and 2HASO2. So this is acidic. So now I can take care of that acidic part. I look at this and I say, okay, I've got 6 oxygens here. I've got 3 and 4. I have 7 oxygens here, so I add the additional water. And then if I look at the hydrogens, I've got 2 here, and so I've got 2 there. Okay, and so that I don't need to add H plus because my hydrogens are already balanced. Okay, and then again, just like you do with anything else that's balanced, you can count up all the atoms and make sure they're the same on the left and the right. and you can also look to see that the charge is the same on the left and the right. Okay, let's do a couple more. Okay, so this one here is going to be basic. Okay, so same thing, let's look at the chlorines. So this chlorine is going to be positive 5 because the oxygen is negative 6 and this has a negative 1 charge. And then this chlorine is going to be minus 1. Okay, so that gives you, that's plus 5 minus 1, so the change in oxidation number is minus 6. Okay, so we went from positive 5 to minus 6. So that means this has been reduced, right? So because it's due to a gain in electrons. Okay, manganese, you've got plus 4 here, and then you've got plus 7 here. Okay, so that one's been oxidized, and so now this one here is minus 6. Okay, this one is plus 3, so in order to get them the same, we have to multiply this one by 2. Okay, so we multiply by 2, and so this is 2MnO2, 2MnO4. The chlorines stay as is. Then you look for the oxygens. You got 4 here. We've got 4 here plus a 3, so we got 7. We have 8 oxygens here, so we add the additional water. We have 2 hydrogens here, none on this side, so we add the 2H plus. Okay, so that's what we would leave it as if it were acidic, but because it's basic, we need to get rid of this by adding the 2 OHs, and so we add 2 OH on this side. So remember, the 2 OHs and the 2H plus, this thing here is going to form 2 waters. Okay, so that's going to become 2 waters. So you've got 2 waters here, you've got 1 water there. So what happens is this water is going to go away, this 2 is going to go away, and so that's why you have just the 1 water here, and then you've got everything else. Okay, so the 2 OHs, and again you can check to see everything is balanced. Okay, one more. Same thing as basic. So here the TEs, plus 4 on the left, because this is negative 6 and it's overall negative 2. So positive 4, negative 6 gives you negative 2. This one, elemental state is 0. Nitrogen, so again we put a 2 here to balance the N2 with just the 1 N. This one here is going to be a plus 4, because the oxygen is going to be negative 8 altogether, and then this one's going to be a plus 5, okay, because the oxygen is minus 6 and you have a negative 1 charge. So same thing as before. Let's look at the change in oxidation numbers. This has gone down by 4, and the other one has gone up by 1. Okay, and so again, where this 2 comes from here, that multiplied by 2 is because we put the 2 over here. Okay, so same as before. So this is plus 2. So we multiply. This one is negative 4. So this one's positive 2. So we're going to multiply it by 2 to get it to be positive 4. So negative 4, positive 4. The other one we leave the way it is. Okay, so you get TE is left alone. This one is going to become 2. That one's going to become 4 because it already had a 2 there, so we multiplied that by 2. Then you look at your oxygens. You got 8 and 3, so that's 11. You've got 12 here, so we add the additional water. And then you have 2 H's here, none here, so we add the 2H plus. Okay, again, this is basic, so now what we have to do is get rid of the H plus, so we add the 2 OHs here. So that gives you 2 waters. And then because you have a water on this side, that goes away. This 2 goes away and just be left with 1. And then there's your reaction. Okay, this one I find you can kind of do it quicker, but it is a little bit more confusing than the other method. The other method's kind of sequentially, it kind of makes a little bit more sense. This one, you might find the numbers get a little bit complicated. Sometimes what you'll find is a reaction works better using one method than the other. So if you kind of get stuck, you can always use the other method. So it's always good if you understand both methods. Okay, so I'll stop there. So you can do these questions here, page 210 number 25. So the same as last time, it's just a bunch of balancing questions. And this time they're asking you to use the oxidation number method. Okay, so I'll stop there. So let me know if you have any questions, and then I'll give you your next lesson on Monday. Okay, stay safe. Bye for now.